Ever wanted to make your mark? Ever felt small?
I need to talk to you now, blood, now!
Willing to pay the price? Taggers only online at bbc.co.uk/1extra.
The world's biggest steeplechase. And away they go. Monty's pass takes it up now. Tremont is showing in front.
The leader's hedge hunter because they jump beaches now.
And the leader is Montefiore by a couple of legs. It's Gunner well, but going to the 20th. Grand Royal is just in front now. Amberley House is absolutely...
The Grand National, Saturday at 1 on BBC One. It's not a one-horse race.
It's all round to Patrick's now on BBC One, party time, under the sky at night.
Good evening and welcome to a very special Sky at Night, our first ever star party extending over 2 nights. We're being joined by some of our very best amateur astronomical photographers. So first of all, down to the beach and Chris Lintott.
Of course, from the UK, the weather's all important, and we've been lucky. Just an hour ago it was completely cloudy, but the skies have cleared, and behind me you can see the young crescent moon and nearby the planet Mercury, a great shot for our astrophotographers. On the beach we've got a nice clear horizon to let us see that, and also illustrate that Selsy's an excellent observing site, surrounded on 3 sides by water, away from light pollution. It's as dark a site as we can get in southern England. The skies were still cloudy when the astronomers set up in the garden earlier this afternoon, and we've got everything here, from the most advanced astrophotographers using small telescopes to those carrying out more traditional visual observing using telescopes like this Dobsonian, which can be swung quickly about the sky, useful when there's patchy cloud about.
Well, tonight we're going to look at Saturn and Jupiter, and we're also going to find some of the major objects because it's the best time of the year for finding them.
Yeah, that's right. Well, hopefully it'll stay clear. So Robin, your telescope's pretty much set up, but you're going to be doing something unusual with it this evening.
Yes, I'm going to use my modified webcam and put a diffraction grating in front of it and do some spectroscopy.
So you're splitting the light into its component parts?
Yes, that's right. What I'm planning to do is to look at a few stars in Cassiopeia, which will show different aspects of the star's origin and what's going on in the star.
So which stars are you aiming for?
I'll start with Delta Cassiopeia and then move on to Gamma Cassiopeia, and then finally try to get a Wolf-Rayet star. It's actually WR1, which is in Cassiopeia as well.
It is a basic telescope. It's only a short focal length scope, but by putting a high quality CCD camera on the back end and with special filters in which we can take really nice wide field images of the sky.
So what filters do you use?
Well, they're actually narrow band filters which only allow a very specific wavelength of light through, but by taking 3 consecutive exposures through those we can build up a colour image.
Well, it's patchy cloud at the minute. We're hoping it'll clear. What will you be aiming for?
A nice target is the Rosette Nebula at this time of year, and then maybe in the later on in the early hours I'll switch on to some other sort of deep sky objects like the North American Nebula, this kind of thing.
And of course these things are fairly faint, so even with a camera like this you need long exposures.
Very long exposures, up to an hour per filter in some cases, to get a nice strong signal for the picture.
The moon's crescent marks the start of our night's observing, and Mercury is hopefully the first of 3 planets. This particular weekend is also the ideal time to view the objects in Messier's catalogue of deep sky objects, galaxies, clusters and nebulae.
Well, back from the beach and back into my study, and I'm joined now by Dr. Alan Chapman. Welcome, Alan.
It's a great pleasure, Patrick.
Well, we've been looking at Messier objects. Messier was a fascinating man, wasn't he?
Oh, he was remarkable. He was an 18th century Frenchman, and he was really a comet observer.
Not a bit interested in clusters and nebulae.
Oh, not at all. He regarded them as a nuisance. Okay. And, of course, as he was looking for comets, the ones he wanted to find were at the very, very approach to the sun, so where they would be very dim and very, very fuzzy. And they looked often like nebulous objects. And so he was so confounded by the number of comets he missed, because he mistook it for a deep sky object, he compiled a catalogue. And they eventually grew between 1774 and 1784 to a list of 103 objects.
It's amazing, isn't it, you know, that nowadays we all use Messier's catalogue and nobody bothers about his comets.
Nobody bothers at all. But of course, in many ways, comets were more important in his time because they were seen as lying at the heart of Newtonian gravitation theory. And so if you could therefore determine the exact orbital shapes of comets, you could use them to prove Newton's laws.
Well, amateur astronomers were important then, they always have been, and they are important now because I suppose astronomy is just about the only science where amateurs and professionals work very closely hand in hand.
It is indeed, and I think the reason for that is that professional astronomy has grown out of amateur astronomy, because until little more than 100 years ago, in England at least, you had no professional astronomers. Everybody who did astronomy paid for it themselves, did it on their own back, as it were, and it was their own pet research. Now, this has meant that England especially, and other countries in Europe, and especially nowadays places like Japan, have very, very rich amateur traditions. And the great thing about amateurs is the fact that you don't have to pay them. They pay for their own time. They can do very, very long watches of observations for variable stars, comet hunting, things of this sort, where frankly, modern professionals who are being paid, as it were, from a salary, just don't have the time.
Alan, thank you very much. And now, back outside to see how the observers are faring.
In the time it's taken us to come up to the garden, it's clouded over. But there are a few cracks, and we're hoping to see the International Space Station pass over in just a few minutes' time.
It makes a series of passes every 6 weeks or so. You can see it for around a week, either in the evening or early morning.
And how bright will it be?
As bright as Jupiter. It's easily naked eye, no trouble picking it up if the cloud permits.
Of course, but that means it's easy to find, so what will you be using to look at it?
Well, I've got a set of predictions from the internet of exactly what time it's going to come over the horizon.
Just a couple of minutes' time?
Yes, a few minutes' time, and I've got a radio-controlled clock with a very accurate time signal, so we know where it is, and a compass for the direction.
And then you'll be using, so that's with the naked eye, but you want to capture images of it, and you're using this video camera.
Well, today we're using a domestic video camera just to capture the trail of it in the sky, and back home we use a telescope to get close-up pictures.
We switched to a night vision camera to avoid disturbing the observers, and watching the space station move against the stars is fascinating. No sign of the space station. Oh, I've just seen it. Literally just overhead. There it is. You can just see it going.
There you go.
Yep. So Bruce, just getting dark. What are you looking forward to?
Well, hopefully, Chris, we're going to be looking at Saturn and Titan, and possibly looking at Jupiter as well.
Yeah, well, Jupiter should be rising later on, but Saturn's up there right now.
It is, yes, and I'm looking forward to hopefully getting some good images.
I'm just trying some test shots on the Pleiades at the moment.
It's a lovely cluster. I can see it with the naked eye. Now it's cleared. But how does it look in the viewfinder?
Let's have a look.
Oh.
We're just starting to pick up some of the stars. The focus seems about right.
Yeah, and you certainly picked up the blue colour of the stars. Yeah,
yes.
They're those young, active stars. I see your telescope's got an electronic drive. Does that mean it can find all the objects for you?
No, I'm one of the old school, I'm afraid. I tend to find things by star hopping and manually.
The largest telescope here is Patrick's own 15-inch in its oil drum dome. It's in perfect condition tonight, providing wonderful views, particularly of the planets. Just a couple of months ago, a team of locals gave it a thorough MOT, which included renovating the drive and removing the very thick mirror to be sent off to have a new coating applied. Tonight, the restored mirror's back in place and it looks as good as new. Although the shape of the glass is important, it's that thin coating of reflective aluminium that sends the light back up the tube towards the observer.
We're looking at comet Machholz, discovered last year by Don Machholz from California, and this is really a nice comet. Peaked at about magnitude 4 back in January. It's now down to about almost magnitude 7, very close to Polaris, but still a very nice object.
So what's it looking like in the telescope?
It's fairly well condensed centre. There's a nice coma which is quite a few arc minutes across. There's just a hint of a tail. Nothing spectacular though, but I dare say if you took a CCD image, long exposure, you'd still get a tail of maybe 0.5 degree. It's really good for me. I'm normally a CCD imager, but really I should do more visual observing. But I actually see this through Patrick's telescope, 15-inch f6 Newtonian. That's what you want to see a comet through, something big, something that will really show it as a comet.
I'm afraid I'm rather an astronomical dinosaur, and my observations are made by drawing, as my Jupiter book here.
Well, here, of course, is your superb, or one of your sets of superb Jupiter drawings, Patrick. I fully agree. I'm a draftsman myself. Give me a load of buttons and I press the wrong ones and I blow a fuse.
And me.
But give me a pencil and I can draw anything. Now, here you have these superb drawings of Jupiter. Here, of course, showing features on the surface from 1967, the great red spot first observed by Robert Hooke in 1667, and here many smaller features which you can really get under good seeing conditions. And you know, although it's true that one can image things with a modern CCD, I think drawing at the telescope with a pencil is a superb discipline. It teaches you how to look, and you're a master at that.
I'm not very good at it.
Oh, you are.
How about, while we're here, going for M81, M82, the pair of galaxies? Yep, come up to that pair, right, and then follow that pair to that triangle. Okay. And then follow that pair in the triangle down to 24, and you will see M81, M82 actually in the eyepiece. How about that? We'll go for that. Okay, excellent.
So, Alan, I've dragged you outside to enjoy what's becoming a really crisp,
love a cold
clear night.
Love cold weather.
Well, just as well. But let's talk about some of the constellations we can actually see. And the most obvious, or as always in the winter sky, is Orion.
Orion, absolutely gorgeous. And you see the belt. You see the sword very, very clearly, and of course if you really get close into the sword, you see the detail of the famous Orion Nebula, one of the about only 3 nebulae completely visible to the naked eye. Then if you follow the belt down, you come to Sirius over there.
In Canis Major,
in Canis
Sirius,
Major,
and then
so in
Minor
Canis
just
Major.
above.
And then of course,
go the other way.
Go the opposite way, you then get Taurus, you get Aldebaran, and of course you get the wonderful little cluster of the Pleiades, which we can just see about 5 or 6 stars. And then Saturn, which of course is moving.
Yep, in the constellation of Gemini.
In the constellation of Gemini, then you have Castor and Pollux, the 2 bright stars in Gemini.
Of course.
And right round over here, of course, you then come to Capella in Auriga the Charioteer, which is a very, very bright circumpolar star, never sets. And astronomers in the past, of course, used to use it for finding north with their instruments, because it will come right down to its most southerly position and then right round to its most northerly position, and astronomers would have employed that as a way of getting an absolutely critical fix on their northern bearings. We have, of course, here Ursa Major, the Plough, the 2 stars of the Pointers going straight there to the pole star, not quite on the pole, about a moon diameter removed from the pole.
And it's one of the advantages navigators had in the northern hemisphere, because
Precisely.
of course at the south there's no bright pole
Not
star.
a sausage.
One of my favourite constellations, the most obvious, is the W of Cassiopeia, just above the dome there.
And she's the queen to King Cepheus, and it's part of an ancient cycle of Greek mythology, where in fact poor Andromeda is chained to a rock and is about to be eaten, but she's going to be saved by Perseus. And Perseus we see coming in over here with his sword, and he slays the Medusa, the beast that's going to destroy, and of course then saves her and carries her off. And they are just so beautiful. And on a night like this, it's like looking into the depths of space. It is so wonderful.
So it's intermittently cloudy and clear, but you're looking at one of the most famous deep sky objects of all.
That's right, yes. It's known as the Horsehead Nebula. It's actually a dark cloud of gas and dust with a brighter nebula behind it, which is why it stands out.
You're getting it tonight, so
That's right.
how are you doing?
Not badly. As you can probably hear from the sound in the background, it's relatively windy tonight. And my telescope is being knocked around a little bit, so the method that I'm using is to stack long time exposures.
Right.
But because the telescope is shaking, I can't stack every frame, and I'm having to be very selective, in fact. And so far in an hour I've got 9 frames.
Well, Chris is having a certain amount of cloud trouble, but not nearly so much as I had with the 50th Sky at Night programme so long ago.
I can't see one single star, can you, George, anywhere? Any luck?
No, I must be able to see it before I can get on to it.
Trouble, of course. Yes, there is the moon. I can see it for the moment. No, it's gone again.
It's gone.
Yes, and there is Saturn for the first time on direct television. Is it gone? Oh, no.
Just as I got it on the crosswires, it blacked right out.
How absolutely typical. There's nothing we can do about it.
I can't move a 24-inch telescope quicker than that.
No, I'm afraid you can't. And so, from Brighton, where the sky is now completely overcast, good night.
Good night.
So that was our 50th anniversary. Live, of course. It wasn't meant to be a comedy show, but it turned out that way, and we saw nothing at all. Well, we left Chris outside with some cloud trouble. I wonder, is there anything better there now?
It's 1:30, it's raining, and the satellite photo shows cloud for the rest of the night. So all we can do is shrug and hope for better luck tomorrow. There have been highlights though. I enjoyed seeing the moon and Mercury from the beach, and others have got some great results.
I've got a number of AVIs using a 2-cam, and so far they've stacked up really well. We've seen colours around the polar caps, also cloud belts around the centre of Saturn, and divisions in the rings, not just Cassini, but some traces of Encke division as well.
But of course we haven't just had the planets on view, and Ian, you've been looking at some of the deep sky objects on offer.
Yes, indeed. I couldn't resist imaging the wonderful Orion Nebula to start with before it got too low. Got some lovely colour views of that, and then moved on to some of the galaxies in Ursa Major and got a really nice view of M81 and M82, lovely pair of galaxies that I managed to get into the same field of view.
And we should remember, of course, that astronomy is not just about CCD imaging or webcams. Martin, you've been doing some visual observing.
Well, I've actually done something that I wanted to do for roughly 32 years, I think, because if I remember correctly, Patrick's 15-inch telescope first appeared on the sky at night in the February 1973 programme when I was a mere 15 years old, and ever since then I've wanted to look through Patrick's 15-inch, and tonight I got the chance. And at about 400 times magnification there was Saturn, and knowing that it was Patrick's telescope made it even more special for me.
Well, that was day one, or rather night one, of our star party. And despite some cloud trouble, it went pretty well, and we got some amazing results. And what I thought we'd do now is to show you some of the very best pictures available when I began doing the Sky at Night programme way back in 1957, and compare them with what we got from my garden last night. And I think you're going to be rather surprised. Here's Jupiter from the Lowell Observatory about 1955. Now compare that with these, taken from my garden last night. As you can see, electronics make all the difference. And here's Saturn, imaged with the best telescopes in the world when I started the Sky at Night programme. And here's what we got last night. There's no comparison at all, is there? Just shows what's happened in the interim.
We've seen those wonderful images, and a lot of work goes into them, not just at the telescope, but processing them afterwards. Now, Alan, we've seen your image of the Horsehead Nebula, and it started off as a raw frame out of the telescope.
Yes, absolutely right. But if you play with that frame by stretching the light curve to bring up the dark areas,
turning up the contrast,
indeed, you can certainly see that there are a lot more stars in the image now, and we're starting to see some of the detail.
Yes.
If I take that frame, do the same thing to all 13, and then add those 13 together, suddenly all the detail that was hidden starts to appear.
Oh, that's lovely. You've got the shape of the horse head really clearly there. It's wonderful. And then almost the next stage for that is to carry on with the processing. And you've been doing that with the image of the Orion Nebula that we got last night.
That's right, Chris. These were taken by Mark Parrish and Ian Sharp using their 10-inch Maksutov Newtonian telescope with a digital SLR camera attached to it. They broke all the rules because they got a fantastic picture with just a 60-second exposure, which we've got here. We've done a dark frame subtraction to get this image here.
So you get rid of the camera noise.
We get rid of the camera noise, and I've also increased the brightness levels on this. But as you can see in the centre, we've actually lost some of the detail. So we've then taken a shorter exposure, which shows nicely the central region of M42, and then we've joined those together to produce this image here.
It's a truly lovely image. It's the result of all that hard work, and, well, fingers crossed for a clear sky tonight.
Absolutely.
And more hard work.
Well, we're using my modest observatory at Selsey, but we now have access to a much larger telescope, the Liverpool telescope on La Palma, and we have with us Professor Mike Bode, who's director of the Liverpool telescope. I'm glad to say in the early days I was, in a very minor way, concerned with the organisation. Mike, first of all, can you tell us a bit about the Liverpool telescope?
Yes, as you remember, Patrick, the Liverpool telescope is a 2-metre class telescope, and it's actually the world's largest fully robotic telescope. It's been operational on La Palma now for just over a year, and since we saw the telescope on the programme last August, the telescope is now fully robotic. We've actually withdrawn the people who were manning the site at the time, and since about November it's been operating fully autonomously.
And here we have pictures live from La Palma.
Indeed.
Could you say what are they?
Yes, well actually the viewers can get onto this site. It's an open site and can see what the telescope is doing, and hopefully all systems will be go for observations later on.
What are you going to look at tonight?
We have a fairly small so-called field of view on the telescope, so we'll be looking way down into the inner regions of some of the things that the observers here have been looking at.
So all we have to do now is to wait till darkness falls.
Indeed.
It's fully dark now and it's a crisp, clear, if a little cold night. We're looking at Comet Machholz. Deep sky objects are being imaged. Saturn is well placed, but I could just see Jupiter rising. So far, night 2 couldn't be any more different from night 1.
John, it gives me great pleasure to be able to show you Saturn through a telescope.
Joining us is Professor John Zanecki, scientist on the probe which landed on Titan just a few months ago. He was able to see Saturn and Titan through one of the amateur telescopes.
You know, these images, this quality of image, about a generation ago, it would have only been professional astronomers using large telescopes that could have produced images of that quality. It's absolutely brilliant.
It's nearly 1 o'clock and it's a beautifully clear night here in Selsey, Mike.
Yes.
What's the news from La Palma?
Well, just as we were going to slew the telescope to the first target, of course the humidity went above our limit, and it and the other telescopes have now closed.
So the clouds have rolled in?
Well, essentially, yeah, we've got cloud rolling in over the caldera. Now this is the sort of thing that can clear, but it'll take a while.
Okay, so what's the plan as far as our observations?
Well, what we're going to do, we've loaded the particular objects into our queue, and they'll be done as the telescope selects them.
Okay, well we'll look forward to getting the results over the web, presumably.
Absolutely, yeah.
Now, one of the beauties of the Liverpool telescope is this scheduling system.
Yeah.
That enables you to take part in rapid reaction projects. And the best example of that is Swift.
Yeah, well, Swift was launched on the 20th of November, and it's a gamma-ray burst mission. It's looking for precise positions of gamma-ray burst, and those positions are then sent down to ground-based facilities such as the LT, which then follow them up.
You've been working with the Liverpool telescope's sister telescopes, the Fawkes project.
Yeah, absolutely right. It's an identical telescope to the Liverpool telescope, a 2-metre class telescope sited on a world-class site on Hawaii, an altitude of 10,000 feet. And I've been lucky enough to be allocated time via the Fawkes project team, and it's been a real enjoyable experience using a world-class telescope. It's a perfect telescope for galaxies, globular clusters and planetary nebulae, things I can't usually get with this small telescope. And you know, being on such a good site with good instrumentation, it's producing some absolutely stunning images, but very easily, because it is designed to be used by schools and universities and even interested amateur astronomers.
And can you talk us through 1 or 2 examples of your work?
Yes, I mean, one of my favourite images taken with the William Herschel telescope is an absolutely lovely image of M51, and it's an unusual image because it was just they were giving us a very small amount of engineering time to test this new camera, the prime focus camera, and just 10 minutes worth of data has produced what I consider to be one of the best ground-based images of M51 ever achieved.
And that's another tremendous sight, Chris. I can see Jupiter there with the banded structure, and there, if I look to one side, I can see almost in a line 4 of the principal satellites.
4 Galilean moons.
Yes.
And one of those, of course, is Europa, the icy world.
That's one that is particularly interesting to me as a space scientist. In fact, I've just come back from a meeting where there were 22 of the world's space agencies gathered together to talk about future collaboration in space. And one of the main areas that we talked about was a possible international collaborative mission to go to Jupiter, and specifically to study Europa.
What would we see when we get there? We know it has an icy surface. We see that icy surface has strange structures on it, and we think there might be an ocean underneath.
Absolutely. I mean, that's the reason why Europa stands out pretty much above all of the satellites in the solar system. Is there an ocean below the surface? if there is, and I must say that all the evidence is pointing to it, the likelihood is that it might be almost warm. And is it possible that there could be the most primitive life forms existing, either now or in the past?
Well, Patrick, I've been rooting around in your study and I found this beautiful little wooden and brass orrery.
I love that orrery. I bought it many years ago when I was a boy in the Caledonian Market, and I think I paid 30 shillings for it.
My goodness, that's a bargain.
It was indeed.
Really is. Now, it was called an orrery because the first one was made for the Earl of Cork and Orrery in Ireland in the early 18th century. What you've got is the sun in the middle, then you have Mercury, then you have Venus, you have the Earth and the Moon. And a complex gearing here means that when you turn this handle, all the bodies rotate around each other in their exact correct periods. And there notice the Moon whizzing around the Earth, showing a phase and even having an inclination in the orbit which corresponds to the exact inclination of the Moon around the Earth. I have to admit, I love brasswork, gears, clockwork and mechanisms, and this is really a gorgeous little
Really
specimen.
lovely, isn't it?
It's lovely.
Well, it's nearly the end of the night and you must have finished your spectra, so what did you manage to get?
Well, first of all, we had a look at Gamma Cassiopeia, and you can see on the image here, you can see the image of the star on the left-hand side, and then the diffraction grating has spread out the colours of the starlight across the screen, and you can see from the blue end going down into the red and even into the infrared.
And Gamma Cass is interesting. It's a B star, a hot, bright star that's thought to be throwing off material.
Yes, that's right. And if you look closely at the spectrum here, you can see a bright spot in the red, and that's hydrogen alpha emission from this material in a disk around the star.
And we're not restricted to stars either.
No, we can look a lot further afield. I had to go at measuring the spectrum of a quasar, and here you can see the spectrum. This is the brightest quasar, 3C273.
Still a long way away though.
Yes, and it's quite faint, so it was quite difficult to get a good image.
And it's an amazing thought, isn't it? That not only can we detect something from 2 billion light years with this little telescope, but we can tell you how far away it is.
Yes, I find it amazing to think that the photons that are hitting the CCD chip have taken 2 billion years to get here.
It's still a beautiful night here. We've had some wonderful views of Jupiter.
Yes, we have, Chris. It's been excellent. And we've had the red spot traversing across the disk of Jupiter, and we've observed it travelling across during the night.
The conditions have been nice and steady and really clear, and the telescope's set up well.
It's 4 AM, the planets are setting, and the astronomers are packing up. Some are still observing the deep sky though, and M57, the famous ring nebula, was one of the last objects captured on a successful second night's observing. It's dawn and I can see Scorpius fading into the brightening sky. It's been a wonderful 2 nights observing. I've certainly enjoyed myself. What have been the highlights for you, Pete?
Well, there have been many highlights tonight, Chris. Of particular interest have been a lot of the faint galaxies which have been imaged throughout the evening.
Several in Leo, for example.
That's right. The Leo triplet has been a particular favourite. M51 in Ursa Major.
The Whirlpool.
The Whirlpool has also been imaged quite considerably.
Don't forget M81 and M82 as well, those 2 galaxies in Ursa Major in the Plough.
Yes, showing fantastic differences in their shapes.
And I saw M57, the ring nebula through the 15-inch as well, which is
that was
wonderful.
Fantastic, fantastic. We struggled a bit with the central star tonight visually, but I think there were quite a few images taken of that as well.
And don't forget the planets either.
No, early on we had Saturn, which was a wonderful sight, and that stayed with us for most of the evening. And then later on we were joined by Jupiter, of course, with some tremendous detail there, and the red spot later on.
And it seems like a long 2 days since we were on that wet and windy beach looking at the Moon and Mercury through a gap in the cloud.
It does indeed, yes. That was a long time ago, it seems.
It was, but it's been fantastic.
Well, that was our star party, a definite success, and I hope you enjoyed it. And congratulations to all those expert astronomical photographers who took part. Now, don't forget, it's newsletter time. If you want a newsletter, then send your stamped addressed envelope to newsletter number 97, Sky at Night, BBC, Birmingham, B1 1RF. When I come back next month, I'll be going over the amazing career of the Hubble Space Telescope, now 15 years old. Until then, good night.
A journey deep into the unknown.
It is dark down here. You try turning the camera around so I can pick up that light over.
Unique images captured on camera for the first time.
You can just see the end of its tail wiggling. I have no idea what that was. Something big went over. Beautiful fish. Some of the patterns they have are amazing.
Amazon Abyss, a week of exploration, starts tomorrow at 7 on BBC One.
BBC One hands over to BBC News 24 in 5 minutes after the weather view from Helen Woods.